Okay, so here's example 3. So remember how we said, hang on, let's write it down. X squared e to the x dx. Okay. So remember back here on our front part, let's go back to it. Down here at the bottom it says, in these examples, you're going to perform integration by parts an equal number of times to the degree of that polynomial. Well, check us out. What's the degree of this polynomial? 2, right? That's my highest exponent. It's right here. How many times do you think we get to do integration by parts? Twice. And here's the thing. You can do integration by parts infinitely many times. There's no statute of limitations associated with doing integration by parts. So whatever it takes to simplify this down. So let's try this on. First thing I can look at is say, okay, I've got a polynomial. I've got this e to the x. I also recognize that I cannot do a u sub with anything that's on here. These are multiplied together, right? All of these are defining characteristics. How do I know how to approach this problem? Well, I can't do a u sub. These are multiplied together, so you should be thinking integration by parts. So let's do it right now. F of x, f prime of x, g of x, g prime of x. So my f of x is that polynomial. My g prime of x is e to the x dx. All right. My derivative is going to be 2x dx. My antiderivative is e to the x. That's just taking derivatives and antiderivatives, Calc 1 style, right? Now I'm going to use that information and put it back over here. So I've got x squared e to the x minus, I like to pull my coefficients out front. So I just put that 2 out front because it's 2x dx. It's all multiplied. We're good. It's all multiplied. All right. However, can I just straight up integrate this? No, we're back to example 1 style, right? Exactly. That's why you have to do a second integration by parts. Now, right? Caution, heads up. This is coming at you. Tune in. I don't know what I need to say to make you pay attention, but here it comes. When you do this second integration by parts, you do the process exactly the same. Where my f of x here is x, so my derivative of that is dx. E to the x dx, the antiderivative here is e to the x. I'm swinging it across and going down to the diagonal. I keep this x squared e to the x minus 2. Where my new integration of parts happens is with the actual integral. Right? Something needs to be going off. Bells are going off. Flashing lights, whatever works for you. This part is where my integration of parts comes in. X e to the x minus this integral here of e to the x dx. Do you see that? When you pull that 2 out, you are going to have to distribute that through there. Let me say it again for the cheap seats. When you have that 2 or any coefficient in front of that integral, when you do integration by parts, you have this first piece to it. That's got to be able to run through there also. And it's a negative 2, right? So let's do it right now. Let's scoot this up a little bit. I actually have x squared e to the x minus 2x e to the x plus 2 integrals of e to the x dx. So x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Now I'm pausing to make sure that's sunk in. Do you see that? It's a video. Pause it, write it down, process it, right? That's what we're looking at. Do you see the pattern? Can you plug it into the formula? These are things that we are asking, right? If you have to do multiple integration by parts, then do that. Okay, how much room do I have on this paper here? Oh, plenty. I think we have plenty. So let's do another one. Here's example 4. I am integrating e to the 2x sine x dx. Oh, there's no polynomial on this one. However, I do recognize e, whenever I'm taking the derivative or the antiderivative, is just going to spin in circles because it's the same thing, right? Sine is going to take a derivative and antiderivative. It's going to flip back and forth between sine and cosine. We just have to worry about the negatives on those, right? Okay. Okay. Now, personally, it doesn't really matter as long as you're consistent. So over here, we said for these two, choose this e to the x as your f of x. That's fine. If you choose the sine or cosine, that's fine. As long as you are consistent, that you choose your f of x as your trig both times or your g prime. And a lot of times they're written in this order. So that's why I also say make your f of x just that e, the e part of it, because it's written first anyway. And this is sine of x dx. So the antiderivative of sine is negative cosine. The derivative of e to the 2x is 2 e to the 2x dx. Do your patterns. Remember I told you back in chapter 7, e never goes away, natural log never goes away. We work with them a lot, and we just keep doing it. All right, now I have negative. I'm going to get this over here a little bit sooner. When you have these that spin in circles, all right, technically, we never write this part of it, but technically, I'm saying this integral now equals these values. So technically, this equals negative e to the 2x cosine x minus a negative. I'm going to put plus 2 integrals of e to the 2x cosine x dx. But I'm back into a conundrum again, right? Because here I have something that I can't take a direct integration of. So we're going to do integration by parts again. And this is where I'm saying keep it the same. If this is e, then you have to keep this as e for your f. And then I come down here and make my trig the anti. So the antiderivative of cosine here is sine. The derivative of e to the 2x is the same, 2e to the 2x dx. Now, keep in mind you've got that 2 in front, right? So, my integral here of e to the 2x sine of x dx is equal to negative e to the 2x cosine x plus 2 times e to the 2x sine of x minus 2 integrals here of e to the 2x sine of x dx. All right, do you see anything familiar? Yeah, other than distributing that 2, check us out. What I start with, which is why I spin back in circles, is what I now have over here. And that's why we do it twice. We take care of this cosine, we come back around so that it's the same thing. Now you just distribute that 2 first, and then we'll combine like terms. And this is also why we rewrite this. Negative e to the 2x cosine x plus 2e to the 2x sine x minus 4 integrals of e to the 2x sine x dx. So that's the point. There are 4 of these on this side, on the right side of the equal sign, 1 of them on the left side of the equal sign. That's why on these problems, these cyclical spin in circles, whatever you want to say, problems, technically we never write this part of it because we know that this is what it is. It just equals this. We just write the equal sign on everything so far, right? But because we're spinning back around and I'm going to have to bring this to the other side, I'm going to add 4 integrals of e to the 2x sine of x dx. Add 4 integrals of e to the 2x sine of x dx, which will give me a total, scoot it up, of 5 integrals of e to the 2x sine of x dx is equal to, and here's where I am going to move it around so I don't have to keep that negative sign in front. Oops. I'm going to bring this up front and put this behind it. It's the same, right? So I end up with 2e to the 2x sine of x minus e to the 2x cosine of x. Keep in mind, this is an indefinite integral, so don't forget you have to put that plus c back there. Now I'm going to divide both sides by 5. Just leave it as a fraction because it doesn't hurt a doggone thing. My integral here of e to the 2x sine of x dx actually equals 2/5 e to the 2x sine of x minus 1/5 e to the 2x cosine x plus c. I'm not going to worry about factoring out any fractions or any to the 2x or any of that stuff. It's not going to make an impact. If you want to, you may, but you don't have to. All right? So the moral of the story right here, if you have an e and you have just a sine or cosine, the other ones don't make an impact, just a sine or cosine, because those are the ones that flip back and forth between each other. So if you have sine or cosine, those are the ones that flip back and forth, sine, cosine. And you have to make 2 rounds of it because the ultimate goal is that you end up with the exact same integral that you start with so that you can combine them across those equal signs. All right, let's practice a few more of those on your homework, and we'll talk about it in class if you have some more questions. Let's do some other.